We'll take a look at viewing file and directory permissions and ownership. We'll want to be sure you know how to display and read these entries. When viewing file and directory permissions and ownership, we can use a number of commands and their options and flags to do so. The main command we'll use for this is the ls or list command. When we've done long listings using the -l option, we've seen a lot of additional information that we glossed over at the time. Now let's take a look a little more closely at the beginning part of a long listed entry to understand the permissions that may be set in that location. When I do a long listing on my home directory as the student user, I can see a number of directories and files. Here we can see that directories have a permission block that begins with D to denote its purpose as a directory. The remaining bits are the permissions for user, group, and other. Here we see a directory that has read, write, and execute privileges for the user. How do we know who the user is? It's declared here. Next, we have the read and execute permissions, but not the write permissions for the group, declared here. Lastly, we have read and execute permissions declared for the other or everyone else. Anyone who is neither the student user or belongs to a group named student would inherit these permissions. So in this way, we configure our permissions in 3 sets of 3s. The first 3 permissions, read, write, and execute, either on or off for the user. The second set of 3 permissions, read, write, and execute for the group. And the third set of permissions, read, write, and execute for other. Enabling and disabling each of these flags allows us to granularly control the access that users, the owning group, and everyone else have to these files and directories. Several specific file types use the first bit to denote what kind of file they are. We can see here the list of characters used to denote what kind of file each one is. A regular file will begin with a simple dash. A directory will begin with the letter D. Links, specifically soft links, will begin with the letter L. And other characters that represent hardware devices such as B and C, or special purpose files such as P and S, exist. We then saw that the next 9 fields are used to denote the file permissions in sets of 3. The first 3 for the user, the second 3 for the group, and the third 3 for other. In a hypothetical scenario, let's consider that we have users and groups configured in this way. User operator 1 belongs to several groups shown in this table. The operator 1 group of the matching name, as well as consultant 1 group. Database 1 user belongs to their own group and the consultant 1 group. Database 2 user belongs to their own group and operator 2's group. And then contractor 1 belongs to the contractor 1 group and operator 2 group. We can take a look at this output to start considering some of the permissions that we see. Have a glance at this output as we discuss these permissions. Specifically, our permissions will always occur in the boxes here. Taking a look at the first file, we see that we have the local directory, or dot, the current working directory, set up as a directory with RW and X, or all permissions, for the user, database 1, that owns the directory. We see that we have RW and X for the second 3 permissions for the group consultant 1 that owns this directory. And lastly, everyone else will inherit read and execute permissions if they're neither the database 1 user or a member of the consultant 1 group. Having a look at another file in this listing, we can discuss the permissions set there. Here we can see a regular file with user permissions for the operator 1 user set to read and write. This means that they'll be able to both view and modify the file, but cannot execute it as that permission is not granted. Members of the group consultant 1 will be able to read only the file. And lastly, anyone that is neither the operator 1 user or a member of consultant 1's group would be able to read and write it within this file. The file in question is named lfile2. This concludes our section on the examples of permissions effects.